Welcome back, friends. Today we are going to study a little bit of chemistry from biomolecules. In this video, we will study structure of fructose, evidence for the structure of fructose, and Fischer projection of glucose. Let us start with structure of fructose. Let us draw the structure of fructose. We know that the structure of fructose has two primary alcoholic groups, one ketone group, and three secondary alcoholic group. So, this is the structure of fructose, having two primary alcoholic group, three secondary alcoholic group, and one ketone group. That means it has two primary alcoholic group, three secondary alcoholic group, and one ketone group. So this was the structure of fructose. Now let us know a little bit more about fructose. The older name of fructose is levulose, and also its plain polarized light is negative. So older name of fructose is levulose, and its plain polarized light is negative. Plain polarized light is negative. Its plain polarized light is negative. So we saw the structure of fructose. This is structure of fructose having two primary alcoholic group at the first as well as sixth position, three secondary alcoholic group at the third, fourth and fifth position, and one ketone group at the second position. So this was the structure of fructose, and the older name of fructose is levulose. Its plain polarized light is negative. Now let us see the evidence for the structure of fructose. There is one chemical reaction which gives the evidence for the structure of fructose. So now we need to know that whenever fructose reacts with mild oxidizing agent, it does not give any test. That means that fructose does not give any test on reacting with mild oxidizing agents like bromine water. Whereas we know that our glucose give test with mild oxidizing agent, that is with bromine water, forming gluconic acid. But fructose does not. So it can be a test for distinguishing between fructose as well as glucose. Now the evidence is that when fructose reacts with strong oxidizing agent like concentrated nitric acid, it splits into two acids, glycolic acid as well as tartaric acid. Glycolic acid is CH2OH, COOH plus tartaric acid, COOH, CHOH, CHOH, COOH. So glycolic acid and tartaric acid. This confirms that there is presence of two primary alcoholic group, three secondary alcoholic group, and one ketonic group. So this is the reaction of this is the evidence for the structure of fructose. So this was the evidence for the structure of fructose. The splitting into glycolic as well as tartaric acid confirms that there is a presence of a ketone group at the second carbon. Now, let us move on to Fischer projection of glucose. Fischer projection of glucose. It is of two types, D and L. D glucose and L glucose. This is nothing, just the position of OH group at the fifth carbon in the structure of glucose. If on the fifth carbon OH is on the right side, it is D-glucose. If on the fifth carbon OH is on the left side, that is L-glucose. So let us draw the structure of D-glucose as well as L-glucose. Now, here, 1, 2, 3, 4, 5. This is the fifth carbon. And at the fifth carbon, OH is on the right side. So, this means that this is D-glucose. And L-glucose is now, this is the fifth carbon having OH on the left side. This means that this is L-glucose. So, D and L is nothing, just the position of OH at the fifth carbon. If OH is on the right side, that is our D-glucose. If on the left side, that is our L-glucose. So this is the Fischer projection of glucose. Two types, D-glucose as well as L-glucose. This is nothing, just the position of OH group at the fifth carbon. If at the fifth carbon OH is on the right side, that is D-glucose. If on the fifth carbon OH is on the left side, on the fifth carbon OH is on the left side, then it is L-glucose. This is also fifth carbon. So this was the Fischer projection of glucose. So we have seen the structure of fructose. That is, structure of fructose is having two primary alcoholic group, three secondary alcoholic group, one ketone group. And then we have seen the evidence for the structure of fructose. That is, it contains ketone group. When on reacting with strong oxidizing agent, it splits into glycolic acid as well as tartaric acid. And here, the Fischer projection of glucose, two types, D-glucose as well as L-glucose. D-glucose is that at the fifth carbon OH is on the right side, and here in the structure of glucose at the fifth carbon OH is on the left side, so that is L-glucose. And also a test for distinguishing between glucose as well as fructose is that glucose reacts with bromine water making gluconic acid, but our fructose does not react with mild oxidizing agent like bromine water. So this was for the video. Thank you.